That roof is on fire. We gonna take it high.
Good day and welcome to today's lesson. So today we're going to be doing chapter 1 of Measurement Mathematics 1B, which is rules of differentiation, which falls under our differential calculus, right? So in real world scenarios, engineers examine a variety of variables. This could be your stress, your temperature, your vehicle speed, current, and torque, right? So this means that it is important, or rather this unit is important for us to understand its principles, to understand its different uniques, so that we are able to apply that knowledge in solving such real world scenarios. So first things first, right? Rules of differentiation. You need to know the standard differential rules in order for you to understand anything that has to do with differentiation, anything that has to do with its applications and its different scenarios and functions moving forward. So the first rule that we're going to deal with, it's the constant rule. So what the constant rule says is that if you have a constant, right, as a function and you want its derivative, it's always going to give you a 0. For example, let's say that we have a y is equal to 5. For example, y is equal to 5. This can be defined as a constant line graph. It can be defined as a function of y defined by 5. So this function of ours is defined by 5, and 5 is a constant. So what this tells us is that the derivative of this function, which is defined by 5, is going to be 0, and it will always be equal to 0 as long as that 5 there is a constant on its own. So other constants can be your 4s, can be your 3s, can be your 5s, as we've done, etc. And then the second rule is the basic power rule. So what the basic power rule states or says is that the derivative, right, of a function with a power n, with a constant of a, right, its derivative will be that constant multiplied by that power n, multiplied by the function to the power n minus 1. Practically, what does this mean? Let's say we're given y is equal to 3x to the power 6. 3 is our constant, it's our n. X is our variable, or it's our function. 6 is our power, right? So this function y, which you can also say f of x, by the way, is defined by 3x to the power 6. So the derivative of this, following the rule, will be that you first take out your constant, which is the 3. It stays that way. Then you multiply it by the power of the variable. In this case will be 6. It is defined here as n. Then you multiply it by then you multiply it by the x that you were given to the power 6. But now there's something that you do to the 6. You minus 1, and you must always do that. So this is what the basic power rule states. This will then give us 18x to the power 5, and that will be the derivative of our function defined as 3x to the power 6. Moving on to the other rule, the sum and difference rule. So this rule states that if you add different functions, f of x, plus or minus, if you add or subtract, different functions, f of x plus or minus g of x plus or minus h of x, then your derivative for that function defined by that addition or subtraction will be the derivatives of each function, each individual function that make up the big function. In this case, the big function is y. The smaller functions are your f of x, g of x, h of x, right? So the derivative of this one big function, which is a y, its derivative will be defined as the derivative of each individual function that make up that entire function. For example, let's say that we have a y defined by x squared plus 7x plus 12 plus 2, sorry. So y is our big function. It's our big F, for example, right? Let me just make it a capital letter. It's our big F, it's our big function. That's our y. And then we have x squared, which is our f1, but that means our f of x. Let's just stick to what's written there. We have 7x, which is our g of x. And then we have 2, which is our h of x. These individual terms, okay, let's just say minus here. Let's just say minus here. Minus, yeah. So these individual terms, x squared, 7x, minus 2, there are different functions that make up this big function. Or let's just say they are variables, just so we don't get lost. They are all variables that make up this big function. So since now we're having addition, since now we're having subtraction, which is a difference of two variables, right? The rule states that for us to find the derivative of the entire thing, the entire function, we need to find the derivative of the individual variables, the individual functions that make up the big function. So our first function, or rather our first variable or term, yes, let's use term. Our first term is x squared. This now will remind you of the second rule. This will remind you of the second rule. The first term will remind you of the second rule, which is the basic power rule. Why? Because x squared has a constant of 1. We usually don't write 1 when it's a constant, right? We have x, and then we have our power n, which is in this case will be 2. And we said that the derivative of a power function is defined as the constant multiplied by your x. No, one mistake, my bad. We're gonna say 1, which is our constant, right? Multiplied by the power. The power in this case is 2. Multiplied by our x, which is what we're given, to the power 2. But then there's something that we do to that 2. We minus 1. Remember, you always minus 1. You don't add it. You don't minus another number like 2 or 3. No, you always minus 1. And then you're going to say plus. We come to the second function. Second function as well, it reminds us of the basic power rule. Why? Because we have our constant 7. We have our x. And we have our power, which is 1. Once again, in this case, you don't write 1. You don't have to. Rather, let me not say you don't write it. You don't have to, because it's just 1. So it doesn't really make a difference. The derivative of this will be 7, our constant, multiplied by our power, which is 1, multiplied by our x, to the power 1, minus 1, plus, we have a 2. This 2 is, oh, not plus, minus. So, minus, sorry, let me just, minus there, yeah. So we have a 2, right? Our h of x is defined as 2, as a constant 2. Yeah? Now, what the constant rule says is that when you want the derivative of a constant, what you're going to get is a 0. So we're minusing a 0 here. You don't have to write it because it's just a 0, or you can write it for formality, or if you just want to know where you're at. Yeah? So now to simplify this, we're going to have 1 times 2, which is 2x, right? 2 minus 1, it's 1. You can just write 1 there, or you can leave it as like this. Really doesn't make a difference. Plus 7 multiplied by 1, that's 7. Multiplied by the x, it's x, right? But then you have 1 minus 1. 1 minus 1 is 0. Okay, let me put the 1 here. Is 0. And then now you can say 2x plus 7. Because you know that anything to the power 0 is equal to 1. Right. Now, okay, I'm just going to erase this because I want to explain the second, not the second, but the following rule, right? So the following rule is the general power rule. You will notice that at first we talked about the basic power rule, and then now we are also mentioning another power rule. It's not really that different from the one that you know, or the one that we've covered so far, but it is kind of advanced a bit, or it's a bit complex. So what the general power rule says is that if you have a function, right? If you have a function such that this function, all of it is powered to a certain value, which is like it may be n, right? In this case, our power is n. So this function f of x is powered to the power n, and you need to find its derivative. So what the general power rule says is that now, for you to find the derivative of f of x, all of that powered to n, you need to first multiply that entire function, right, with n. But then you must also do something to the n that is a power. You must minus 1. That's what it says here. You multiply the n, meaning that you bring down that n, that number, that n, you bring it down, that exponent, you bring it in front of that function that is powered to n. And then what you do to that n that is at the power, you minus 1, which is quite similar to the basic power rule. But then they introduce something else. They say that you must also multiply this entire thing, the n multiplied by the function to the power n minus 1, you must now multiply it by the derivative of what's inside the power. So it's basically, here you derive 2 times. What the general power rule says is that you must derive 2 times. In a nutshell, you are deriving, but as you are deriving, you also derive. What are you deriving? You're deriving your function. Let's do an example for you to see this. So let's say we have our y, which is equal to f of x. Okay, let's not, yeah, it's fine. We can say that because y is equal to f of x anyways, which is, let's say it's 3x. That's our function. Or let me just say y, because I feel like that may confuse some. Let me just say y. Okay? Or let me just say g of x. Yeah, let me just say g of x. So you have y is equal to g of x equal to 3x, right? But this 3x, all of it is powered to 3. And we need to derive this, right? We need to follow the general power rule. So you notice that this is different from this, from the example that we used for the basic power rule. How is it different? It's different in the sense that this 6 is only an exponent for the x. It's only powering the x. It does not power the 3. But in this case, this 3 is not only powering the x, but it's also powering the 3, which makes things different. So, following the general power rule, the derivative of this will be, you bring down your n, which is 3 in this case, you multiply it, right? You multiply it by the original y function that we were given as defined. But now you do something to your exponent. You minus 1. Right. You multiply again, you're not done. We are deriving, but with us deriving, we also need to derive here again. What are we deriving now? Now we are deriving f of x. What's inside the brackets, that's what we're deriving. And in this case, this is given as 3x, right? This is power to 1. So our derivative will just be 3. Why? Because this will be x1 minus 1, which will be x to the power 0, which will be 1, times 3, which is 3. Right. So now this 3, don't mistake it with this one. This 3 is the derivative of what's inside the brackets of the 3x. It's not the 3 that was the exponent. It's not the 3 that was inside here. Well, it is, but it's not at the same time. Right. It is in the sense that it's the 3 that you multiplied with 1 here. But it's also not that 3 because this 3 is the derivative of the entire thing. Fine. Is equal to, right? So 3 times 3 is 9. And then we have our brackets, 3x. And then 3 minus 1, that's 2. 9 multiplied by 3, 3, 3 squared multiplied by x squared. Now you have to remember your high school rules, right? In high school, we are taught that if you have m multiplied by n, all of that in brackets powered to a p, this is the same as m p dot n p. I forgot what they call the rule, but it's a exponential rule that you cover in high school. So that's what we did here. We brought the 2 as an exponent to the x and to the 3, and that is going to be 3 squared. 3 squared is 9. 9 times 9 is 81 x squared. Right. And then, still as part of the general power rule, now let's say that, I'm just gonna erase here. Let me erase here again. I'm pretty sure now you've written all of this down. Let's now say, for example, you have a function such that you have a constant as a numerator, and you have a function as a denominator, or rather a variable term, or a term with a variable. Ne? The general rule or general power rule says that if you have c over f of x and you want to find the derivative of that, what you're first going to do is that you're going to take the constant out. C is our constant, right? You're going to take it out and it will be in front of the derivative sign. And then what you're going to do, you're going to deal with the function, which is your denominator. And then now, what you're going to do to make things simple for you, you're going to take that denominator, you're going to bring it up to your numerator. And when you bring it up to your numerator, it's going to have a minus 1. It's a reciprocal. If you have 1 over 2, right, and you want to bring it up as 2, it must have an exponent of minus 1. These things are the same. It's 1 here. When it goes up, it turns into minus 1. These things are the same, right? These things are the same. If you want, or you have 3 over 4, and you want to make it 4 over 3, all of this must be to the power minus 1. Reciprocals. So that's what they do here. So to make things simple for you, you must take that f of x, or that function, from your denominator and make it a numerator. But when you make it a numerator, you must always remember that it must have a minus 1, right? To show that you brought it up from where it was not. And then from there, you're going to do the same thing that you did here. You're going to multiply. You're going to take this down. Let me just write it here. You're going to say c. This thing will be equal to c, which is a constant, multiplied by your f of x minus 1. But then you're going to minus 1 again. Why are you minus 1 again? You are following the power rule. It's still the power rule. This is our n, basically. So now your n, what you do to it, you minus 1. You multiply by the n. What is the n in this case? Minus 1. And then you multiply by the derivative of this function, just like we did in that previous example for this rule. Now let's do an example. Yeah? Let's do an example. Let's deal with it practically. Obviously this, okay, let's simplify this. Minus 1 times c is going to be minus c, multiplied by f of x to the power minus 2, right? All of this multiplied by the derivative, which will then simplify to this. So now if you want to bring this down to your denominator, it's in your numerator now. If you want to bring it down to your denominator, this 2 will be a positive 2, just like here. Remember, reciprocals. Okay, so we can erase this. And then we're now going to do an example, ne? So that you can see how it works practically. Let's say we have an example defined as y is equal to mm, 5 over x to the power 4, right? Okay, we used 5 before. Let's just say 8. Okay, let me just 8 to the power x divided by x to the power 4. Yes, that's our function. We have our function y equal to 8 to the power, no, equal to 8 divided by x to the power 4. Yes, or 8 over x to the power 4. That is our function defined as that, or that is our equation. And now we want the derivative of y, right? We want the derivative of y. First things first, what we're going to do, okay, let me erase this. What we're going to do is that we're first going to take up this denominator, which is our x to the power 4, and make it our numerator. We're going to leave our constant as it is, and then we're going to multiply it by x to the power minus 4. Right? This is the same thing. We just brought the denominator to a numerator, and then we multiplied it by 1, minus 1, sorry, just to show that it's a reciprocal. And then from there, now, in finding our derivative. So, the derivative now of this equation or this function, remember, you must take your constant out. Okay? Take your constant out. When you take your constant out, you multiply it. Right? Now, what are you multiplying this constant out with? You come here. You come here. This is the same old power. So we're going to use the same old basic power rule. Because now we're focusing on this x to the power minus 4. We bring down the constant, or rather the number that this x is powered by, which is in this case will be minus 4, right? Remember the minus 4. It must be a minus as well, because your power here is minus 4, and it's a minus. Even though it's a reciprocal and all that, it's a minus. Then you multiply it by that x to the power minus 1 minus 1. Minus 4 multiplied by x to the power minus 4 minus 1. And then you multiply it again. What are you multiplying it with? You are multiplying it with the derivative of our function. Remember, this is the same as this. Yeah? It's the same as that. So since it's the same as that, we want now the derivative of x. What is the derivative of x? Remember, x has a constant that it's invincible. That is English. Invincible. Yes, invincible, which is 1. Right? That is not, like, we don't write it. You don't have to write it. But if you want to write it, you can always write it. But it has that constant that is 1. Right? And that x now, when it's inside that bracket as a function, it has a 1 here. And we know that the derivative of 1x will be 1 multiplied by 1 multiplied by x to the power 1 minus 1, which will then be 0. And then that will be x to the power 0. And anything to the power 0 will be 1. Multiplied by the constant in front of x, which is in this case 1. So here, we're going to multiply it by 1. This will then be equal to 8. Okay, let's just multiply it. Yeah? 8 multiplied by 4, it's 24. No, it's 32. Sorry, it's 32, right? So minus 32x minus 4 minus 1. That's going to be minus 5 multiplied by 1, which will then be negative 32 divided by x to the power 5. One thing that you'll notice, right? One thing that you'll notice is that there's a certain trend when it comes to functions that are denominators when you're given them. For example, here you are given x to the power minus 4, to the power 4, sorry, as your denominator. You will notice that your derivatives, they will always have a plus 1. Right? They will always have a plus 1. Why? They will always have a plus 1 in the sense that your derivative here is a 5, and here it's a 4, meaning that you added 1 to get 5. That's a plus 1. But then you must also remember that plus 1 is a reciprocal of minus 1, which is what we say that we must always do here in our basic power rule. You must always minus 1 to the power, just like we did here. And then when this comes down to your denominator, it will be a positive. When this comes to your denominator, it'll be a positive. So in most cases, I'm not saying that's always the case, in most cases, if you're given a function that is, or rather that has a denominator, which is a function to the power of a certain value, in most cases you'll find that the derivative will be a plus 1 of that value and other values as well. In this case, we had a x to the power 4, the derivative is x to the power 5. In our example, our function f of x was powered by 1, even though it's not, you don't see it there, but there's a 1 there, right? There's a 1 that we don't write, right? And now its derivative has a 2. Sorry, its derivative here has a 2, but here there's going to be a 1 that you don't see. But now the derivative here is a 2 plus 1. Right, okay. Moving forward, now we come to the quotient rule. Now, we come to the quotient rule, which is basically the division rule, one would say. So, what does the quotient rule say or tell us? What the quotient rule tells us is that if you have a function, or if you have an equation, or a graph, or something defined by f of x over g of x, h of x over t of x, a function over another function, the derivative of that, it's quite an equation, but anyways, it'll be the function that is on your denominator, which is g of x in this case, multiplied by the derivative of your function that is on your numerator minus the derivative of your function that's on your denominator multiplied by the function on your numerator, and all of that will be all over the square of your function that is on your denominator. The quotient rule says that if you have a function or an equation defined by function 1 or function f of x over g of x, the derivative of that will be your function, which is your numerator f of x, its derivative, multiplied by your function on your denominator minus the function on your numerator f of x multiplied by the derivative of your function on your denominator g of x. All of that being all over or divided by the square of the function that's on your denominator. So it must always be the derivative of the function on your numerator multiplied by the function on your denominator that minuses the derivative of the function of your denominator multiplied by the function on your numerator. So the product must stay like this. It must always be g of x multiplied by the derivative of f of x minus the product of f of x multiplied by the derivative of g of x. Here in your numerator, it must always stay like that. You can't change these products. You can't have the derivative of g of x here multiplied by f, and then you have the derivative of f of x multiplied by g of x. You can't do that. It must always stay like that. Okay? So, example, let's say that we are given y defined by 2x over 9x cubed plus 7x. You have a function, an equation defined as 2x over 9x squared x cubed plus 7x, and you're asked to find the derivative of this. 2x is our f of x, right? 9 cubed multiplied by 9x cubed plus x plus 7x is our g of x. So those are the two functions that we have here, right? Following the rule now, the derivative of y, which is defined by 2x all over 9x cubed plus 7x, sorry, it is going to be equal to the derivative of 2x. The derivative of 2x is going to be 2. Remember your basic power rule. It's going to be 2 multiplied by the function on your denominator as it is, g of x, 9x cubed plus 7x, sorry, minus the derivative of your denominator. We have 9x cubed plus 7x. Remember your sum rule. You find the derivative of the first term, you find the derivative of the second term. Derivative of the first term, 9 multiplied by, okay, 3 comes down, you multiply it by 9, right? And then you say multiplied by x to the power 3 minus 1. This will give us 27x squared plus 7x, derivative, basic power rule, it's going to be 7. All of this must be multiplied by, your f of x, your numerator, which is 2x. All of that to the power 9x cubed plus 7x to the power 2. This will then, you just multiply now, you do your simplification. 2 times 9 is 18, x cubed plus 14x minus 54 x cubed, because you're multiplying this 27x squared by that 2x, and you must also multiply the 7 by the 2x minus, and the reason why we're saying minus is because of this minus. Your 27 is positive, your 2x is positive. Positive multiplied by positive, that's a positive. Positive multiplied by a negative, that's a negative. So 27x squared, which is positive, multiplied by a 2x, which is positive, it'll be 54x cubed, which is positive. And then you multiply it by the x, the minus, which will then be a negative, right? And then coming to the 7, it's going to be minus 14x. Now, all of this will be divided by the square of our denominator. This will then be this 14 and this 14, they're going to cancel each other. And then 18 and 54. 54 minus 18, that's 36. Yes, 36. So negative 36. Negative because, negative 54, it's bigger. Negative 36 x cubed will be divided by 9 x cubed plus 7 squared, and that will be the derivative of our y. And then moving on now to the last rule that we're gonna focus on, the standard rules all of these rules that we've talked about, you have to know them by heart, by the way. You have to know all of them by heart. Okay, let me just leave space here. We're gonna deal with this space. Yeah. So you need to know these rules by heart. All of them. You must know all of them by heart. Okay. Coming to the final rule, right? So the final rule is a product rule. And this product rule, what it says is that if you have two functions multiplying each other, if you have two functions multiplying each other, f of x by g of x, then the derivative of that product, right? The derivative of that product will be a sum of two products. The derivative of the product of two functions will be a sum of two different products. What are these products? You ask yourself. The first product will be the derivative of one of the functions multiplied by the other function. The second product, once again, will be a derivative of a function multiplied by the function, which is another function. In this case, because now I'm just playing with words. In this case, we have a f of x, we have a g of x. So if we were to multiply g of x and f of x and then get the derivative of that, then the derivative of that would be f of x multiplied by the derivative of g of x plus, it's a sum, the derivative of f of x multiplied by the function g of x. Ne? So, example, y is equal to 2x multiplied by 9x cubed plus 7x. You'll notice that I used the same values that I used for the previous example, right? So initially, in the previous example, we had a quotient rule, so we had 2x over 9x cubed plus 7x. Now we're doing the product rule. We still have the same functions, but now these functions are multiplying each other. We have 2x multiplying or multiplied by, in brackets, 9x cubed plus 7x. Now, the derivative of this function defined by 2x multiplied by 9x cubed plus 7x is going to be equal to, right, first function, our f of x, 2x, multiplied by the derivative of the second function, which is g of x, which is 9x cubed plus 7x in this case. That will be 9, start with the first one, remember, sum rule, 9 multiplied by 3, which is the exponent, multiplied by x to the power 3 minus 1. Just a reminder, 9 multiplied by 3 multiplied by x to the power 3 minus 1, which will give us 27 x squared plus 7. Derivative of 7x plus, this is our first product. This is, wait, let me do something. Sorry, I just want to use a different color just to emphasize this. This is our first product. Yeah, this is our first product. Then let's go back to red. Sorry about that. So this is our first product, right? Our second product now will be the second function, which is 9x cubed plus 7x, right? Multiplied by the derivative of the first function, which is f of x. The derivative of f of x, which is in this case 2x, will be 2. This is our second product. Right. And then all of this will be equal to, yeah? All of this will be equal to, you're simplifying now. You're just simplifying. It'll be equal to 54x cubed plus 14x, right? Plus 18 cubed plus 14x, which will then give us 72x cubed plus 28x. You'll notice that these values are similar to the values that we got here. But yeah, and then that will be our standard differential rules. Now let's do 1 or 2 examples just to, brush up or see how these rules are going to be applied. So example 1, right? We have a function which is y equal to root 1 plus root x. So that 1 plus root x is inside already. It's inside the bigger root. So we have a root inside a root, basically. We have a root that is inside a root. So we can always express this function as 1 root x to the power 1 over 2. You know that a square root is equal to 1 over 2 when you do it as a power, right? So this means that we have a function inside of a function in another way. So which rule are we going to use? We're going to use the general power rule, because this is our f of x. In a nutshell, this is the case that we have here. This simplified looks like this. So this is the case that we have, and that's the case that we're going to work with. So we're going to work with the general power rule, but also be aware of this. Be aware of this. So this means that somewhere we're going to have a f of x. Somewhere we are going to have a f of x. Ne? Okay. So let's solve the problem. So now, what do we do in this case? Let's leave it like this so that it's easier for us to solve. The derivative of y defined that way above, right? It's going to be 1 over 2, which is our n, by the way. It's our n. It's going to be 1 over 2 multiplied by our f of x as it is to the power 1 over 2 minus 1, right? Multiplied by the derivative of the function. We have this function, which can be expressed as 1x to the power half. We need to find its derivative. And it's a sum, so you use the sum rule. So first derivative for the first term is a constant, so we use the constant rule. It's going to be 0 plus the second term, general power rule. It's a function to the power of something. It's a variable to the power of something. So we have 1 in front of it, right? That's our constant. We're going to multiply it by our power. So we bring down the power, 1 over 2 multiplied by x, 1 over 2, we minus 1. Remember, always minus 1. And then we close our brackets, right? We close our brackets, and this is going to be equal to 1 over 2, 1 plus root x minus 1 over 2 multiplied by, this is 0, this simplified will be 1 over 2 x negative power as well. So now we have these two cases and we're multiplying them with each other. You can bring your constants to the front. If you bring them to the front, it's going to be 1 over 2 multiplied by 1 over 2, such that we are left with 1 plus root x minus 2 multiplied by x to the power minus 2. We took this one to the front. This one stayed in the front, right? It's like the common factor in a way. So you can even do this. Doesn't really change anything. Sorry, it's not. It is not. It's not a common factor because we don't have an addition or subtraction sign. So sorry, my bad. You just multiply this variable with this variable because this variable is not powered by this exponent, just like this variable is not powered by this exponent. So you can express it like this, such that it's like that, for you to get an idea. Otherwise, it's not part of that, which is why you can multiply this 1 over 2 by that 1 over 2. And then the remaining terms, which is this one and this one, you multiply them with each other. Ne? You multiply them with each other. Now we're going to do something about these. I want to express them in another form so that you understand. So 1 over 2 multiplied by 1 over 2 is 1 over 4. Multiplied by, this is negative, right? This is negative. What it tells us is that this is a reciprocal, because this is a numerator, this is a numerator. So since it's a reciprocal, we take it to the bottom. And when we take it to the bottom, it's going to be a positive 1 over 2. Multiplied by 1 over x to the power 1 over 2. But then, initially I said that 1 over 2 as an exponent can be expressed as a square root. So we're going to have 1 over 4 multiplied by 1 over root 1 plus root x. Ne? Multiplied by 1 over root x. Now, I want you to remember something from high school. When it comes to roots and set forms, things of that nature. If, for example, you have root 5 multiplied by root 3, your answer to this will be root 15. Oh, okay. Going to be root 15, which is a product of 5 and 3. If you have a root 5 multiplied by a root 3, you basically have a root, and then inside that root you have a product of the values that were inside the initial roots. That's the third principle or something. Third, yeah, for values in third form, yeah. So now we have a similar situation. Oh, also this applies for values that are not the same. Well, it also applies for values that are the same, because root 2 multiplied by root 2 will be root 2 multiplied by 2, which should be root 4, right? But 4 can be expressed as 2 to the power 2. And then this square root can be expressed as 1 over 2. These will cancel, and then that will be 2. It's just a matter of 4 being, it's a matter of 2 being a square root of 4 in this case. Otherwise, it works for anything. So in this case, we have our x here. We have our 1 plus, okay? We have our 1 plus root x, right? Inside this big root, inside this big root, we have this value here, we have this value here. It's one value. So following the same principle of 5 multiplied by 3, in this case, we're going to have 1 over 4 big root x multiplied by 1 plus root x, close brackets, under that big root. So now this is a product of these two values, similar to what I was showing you here. And this will be our answer, basically. Let me just write it in a more neat way. 1 plus root. This will then be our answer simplified. The derivative of root 1 plus root x will be 1 over 4 root x multiplied by 1 plus root x. Then, moving on to this example, the next example. So example 2 says that we must find the derivative of x cubed minus 1 over 2x cubed plus 1, all of that to the power 4. All of that to the power 4. So that power 4 applies to that x cubed minus 1, which is your numerator. It also applies to that 2x cubed plus 1. This can be expressed as f of x over g of x to the power n. Are you hearing me? This function that we're giving here, this equation that we're giving here, which is x cubed minus 1 divided by x cubed divided by 2x cubed plus 1 all to the power 4, right, can be expressed as f of x divided by g of x, all of that to the power n. And then when you see it in this form, it'll give you an idea. It'll give you a number of rules that you're supposed to use. It'll give you the actual rules. You have an idea of the actual rules that you can apply. Because when you look at it like this, now you remember that the general power rule is the one that talks about a function that's inside the power n. You remember that the quotient rule is the one that talks about a function over another function. So what this tells us is that we're going to use the general power rule while also applying the quotient rule. So you have two rules in one. And then also, when you look at your functions, there's a minus, there's a plus. So that sum and difference rule is also here. It will also apply. And then you have constants. The constant rule applies. And then you have a basic exponential function. The basic power rule applies. So the first 6 rules, basically, I think there's 6 of them, I'm not sure. But the first rules that we use, except the product rule, they are all in this derivative, which is why it's important for you to know them. But the most important rules that will help you and guide you into finding your answer are the general one and the quotient rules, because they are the ones that play a big part. Because the basic power rule, you know how to use it. The constant one, you know how to use it. The sum, you know how to use it, because they're basic and yeah. So now, how do we solve this? How do we solve this problem that we're given here? Because we're saying now that we have a quotient rule that will be inside a general rule. So how are we going to go about this? You must remember that according to the general rule, we're going to take n, we're going to bring this n down. We're going to multiply it by the original scenario that we're given, which is our f of x over g of x to the power n. But there's something that we do to that power, minus 1. And then we multiply by the derivative of what's inside that power, that function. This is the rule that we are going to be following. This is what we are going to be following in solving this case. This is your answer, basically. As long as you know your rules, you finish. You finished, you're done. You finished or you finished, or you're good to go. Either way. So let's do it practically. So our n here is 4, right? So we bring down that 4. We multiply it by the original. X cubed minus 1 divided by 2x plus 1. All of that to the power 4, we minus 1 from that 4. Multiply. We need the derivative of this entire thing. Right? We need the derivative of that entire thing. So we're going to use the quotient rule. According to the quotient rule, we are supposed to first, wait, let me check. Yeah, according to the quotient rule, we're supposed to find the derivative of the numerator. So the derivative of the numerator will be 3x squared, right? X cubed. You bring down the constant, the power, you multiply it by the x to the power 3, you minus 1. And then this is a constant, so it's going to be 0. You multiply it by g of x minus, right? We do the derivative of the second function, which is a denominator. You multiply that power by your constant, which will be 6. X, 3, you minus 1, 2, plus 1, it's a constant. You multiply by your numerator, which is f of x, which will be x cubed minus 1. All of that, you will divide it by the square of your numerator, of your denominator, sorry. This will be equal to 4, right? x cubed minus 1 over 2x cubed plus 1 to the power 3 multiplied by, we simplify this will be 6x 5 plus 3x squared. We simplify multiplication minus 6x squared multiplied by that will be 6x to the power 5. Then 6x squared multiplied by minus 1 is going to be a negative. But because of this negative, it's going to be a positive 6x squared. All of that will be divided by that denominator there, which is squared, which we're going to leave as it is. Let's now, we need a page, sorry, we need a page, a blank duplicate page. Let me just see the slide. Yeah. Right. So, what did we have here? We need to continue from this. Okay. So, what we're going to do now is that we're going to simplify this. We're going to put this as it is, and then we're going to simplify this and look at a way forward. So, that is going to be equal to 4 multiplied by x cubed minus 1 all over 2 cubed minus plus 1 to the power 3 multiplied by your 6x to the power 5, right? This, it cancels with this. And then you're going to be left with, because they're equal, everything is the same, and then you're going to be left with 3x squared plus 6x squared, which is going to be 9x squared divided by the product, remember? Not the product, the denominator squared, sorry. Now, remember, here, right, here, all of this is to the power 3. So if all of this inside the brackets are to the power 3, this means that we can express it as x cubed minus 1 to the power 3 divided by, it's multiplication here, 2x cubed plus 1, all of that to the power 3. This thing, this notation is the same as that notation. It means the same thing. We did not change anything. And then we multiply it by, we multiply it by 9x squared divided by 2x cubed plus 1 to the power 2. This and this, these two, they are the same, aren't they? So given that our denominators are the same, we're going to apply the same rule that I talked about earlier. The product rule. Okay, no, it's a different one, sorry. If m is powered by p multiplied by m powered by q, right? The product of this, or the answer, will be m to the power p plus q, because our, is it a denominator or the no, it's not a denominator, the value or the variable that is being powered by is the same. Forgot the English for that, but it's the same. So moving on from that, we're now just going to multiply the 4 by the 9. This 4, we're just going to multiply it by the 9, which will basically give us 36x squared multiplied by x cubed minus 1 to the power 3, all of that to the power 2x cubed plus 1, 3 plus 2, which will then simplify to 36 squared x cubed minus 1 cubed to the power 2 cubed plus 1, 5. And then that will be our final answer for this equation. Right? Then, last one. The last one now, example 3. it says that we have x plus root x plus, no, sorry, we have x plus root 1 plus x squared. All of that powered to n. We don't have a value now, we have an n. It's quite interesting. It's an interesting one. The exponent is not a number in this case. It's a variable n. It's a term n. So this now needs you to understand the rules. That's why it's so important for you to understand the rules, because this is a question with just one as a number. Just one as a number. Otherwise, it's just filled with variables. Y is equal to x plus root 1 plus x squared, all of that power to n. So it needs you to understand the principles as they are. It needs you to understand the rules as they are and how they are applied and how they work. So to simplify this, we can express it as f of x to the power n as it's given here, right? And then our f of x, right, is defined by a sum of two terms. So we have a sum rule, right? But the second term has a rule as well, because the second term is in a third form such that it's a function inside another function. That sounds ridiculous, I know. F of x is equal to g of x. G of x is equal to h of x plus maybe p of x, right? But our p of x has an n, which in this case is the root. I'm not trying to complicate things, but I want you to look at how like the depth of the equation and the number of rules that we have to use. So in this case, what we're going to do is that we're going to find the derivative of the function f of x, right? But then not only are we finding the derivative, but we also need to find the derivative of the term that is inside f. This will make sense when I'm doing it practically, but I just want you to understand, just by looking at it, the amount of work that we have to do, the things that you must not overlook. We have the n here. This is a general power rule. General power rule says that when you're finding a derivative, you must also find the derivative of your function, which in this case will be the x plus, we need to find the function of that. But we don't stop there. We don't just find the derivative of this. We also need to find the derivative of what's inside it, which is in this case will be this. Fine, let's do it practically then. Let's do it practically so that you see what I'm talking about. So, in finding the derivative now, right, we're going to bring down this n. We're using the general power rule. We're going to multiply it by the original equation as it was given. To the power n, we minus 1 from that n. We multiply it again. But now when we're multiplying it, right? When we're multiplying it with the derivative of what's inside, right? So we're going to use the power rule. The sum rule. So according to the sum rule, the derivative of the first term, which is x, will be 1 plus. This one is the same as 1 x squared to the power 1 over 2. It's the same thing, right? So the derivative of this would be 1 over 2 multiplied by, right, multiplied by 1 plus x squared to the power half minus 1. But we're not done. We still have a function inside that we need to solve. So this is what I was talking about, right? We're finding the derivative of this, we use the original form, we multiply it by its derivative. But the derivative also has a derivative that we need to find from inside. So it's a function to another function to another function. It's a derivative to another derivative to another derivative. The fun in maths, right? I know. So from here, so you minus 1 and then you multiply once again. It's still inside the brackets. You're not multiplying the entire thing because the derivative that you're finding it for this term. So the derivative that you're finding, you're multiplying it by that term, or you're multiplying it to that term. So the derivative of 1 plus x squared is just going to be 2x, right? Brackets. This will be equal to, I'm just going to remove this, right? Just going to remove it. So if I'm removing it, let me take my thing up. We're going to put this as it is. We're going to bring it down. N minus 1, right? Multiplied by. And then here, so the 1, it's 1, so it's going to stay as 1. We're going to bring it down as 1. The half, for now, we're going to bring it as half. Multiplied by 1 over 2 minus 1, that's minus half. And remember, minus half is a reciprocal, right? If it's an exponent. So this means that we must bring this down. And then when we bring it down, it's going to be in this form. Okay, let me just write it down. It's going to be 1 plus x squared half, right? Then multiplied by 2x. We're still gonna come to this. I want us to focus on this first for us to simplify this first. So we're gonna bring it down as it is. And minus 1 multiplied by. Now, okay, 1 plus. Now coming into here, this is a product, right? This 2 is a denominator. This 2 is a numerator. So they do what? They cancel each other. Yes, they cancel each other. So when they cancel each other, now we're going to have this x, because this x is a numerator as well. You must remember this is divided by 1. So it's going to be an x multiplied by 1 multiplied by 1, which is going to be x, divided by 1 plus x squared to the power half can be expressed in Z form as that. Close bracket. This is plus. Right? Now we're going to take this, we're going to multiply it inside, because we still have a multiplication sign here. We've done simplifying this. Now it's time to simplify the entire thing. So this entire term multiplied by 1, it's going to come down as 1. Just the way it is. Right? Plus, we're going to multiply this thing again by x. This is x. Sorry. Okay. Let me also fix this. This is plus. This is x. 1 plus x squared. And then we're gonna say. Sorry. Wait, no, we're complicating things. Wait, sorry. No. Because if we do that, if we multiply this inside here, it's just going to become more complex, and that's what I realized when I paused. So, sorry, excuse me. So what we're going to do, we're going to simplify these as individual terms before multiplying them, right? So coming into this n multiplied by x plus root 1 plus x squared to the power n minus 1, I want you to notice something on your exponent. Your exponent is written as n minus 1. It's a difference of two terms, right? It's a difference of two terms. Now, this n minus 1 is powering just only the x plus this what's inside, right? And remember when I said that if you see a minus as an exponent, it means that it's a reciprocal of something. There's a rule that I want you to remember from high school now. In high school, if we have m to the power p divided by m to the power q, right? Your answer to that would be m to the power p minus q. The reciprocal. If you bring this up, it's going to be mp multiplied by m minus q. The bases are the same. That was the term I was looking for. Bases. Yes. The bases are the same. So since your bases are the same and you're multiplying, you add these two. And when you add these two, it's going to be a p minus q. So in this case, we are given it in this form. Meaning, we can express this entire thing as x plus root 1 plus x squared, right? Multiplied by n, to the power n, multiplied by x plus root 1 plus x squared, root close brackets minus 1, multiplied by the entire thing. We still need to resolve this. Right. Meaning, if it's expressed in this form, which is in this case now this form, we can bring it back again and we can express it in this form, such that we're going to have n multiplied by x plus 1 plus root 1 by x squared to the power n divided by x plus root 1 squared 1. Don't have to write it, but we're just going to write it anyways. Now, I want us to come here. 1 plus x divided by root 1 plus x squared. I want us to come there and I want us to simplify it. So, when adding fractions, right? When adding fractions, the simplest way to add fractions is for you, when you're adding or subtracting, you just cross multiply. You cross multiply the 1, which is your numerator, by the denominator of your second term. You multiply, or you cross multiply the denominator of the first term with the numerator of the second term. But because there's a plus sign, these things, you won't take this to the side and it will disappear. For example, let me just do an example. If you have 1 over 1 equal to x over root 1 plus x squared, when you cross multiply this, right, in hopes of solving it, you are going to have root 1 plus x to the power x squared, equal to x, because you cross multiply, right? But in this case, you don't do that because it's not an equal sign, it's a plus sign. What you're going to do is that you'll say 1 multiplied by root 1 plus x squared, which will give you root 1 plus x squared, right? Plus 1 multiplied by x, it's going to give you x, divided by this thing, multiplied by this thing. Or you must also multiply your denominators as well. So you cross multiply and then you multiply your denominators as well. So 1 multiplied by 1 plus root is going to be 1 plus x squared over a root equal to, let me use a different color. I want to use a different color to show this. You have this term here. You have this term here. Right? These terms are the same. And there's a multiplication sign between them. It's not an addition sign. It's not a subtraction sign. It's a multiplication sign. So what happens in this case? If you have a multiplication sign and you have a denominator similar to the numerator of the value or the term across it, just like we did here, what are they going to do? They're going to cancel each other. Cancel. And when they cancel each other, we are now, we are now going to have n multiplied by x plus root 1 plus x squared, all of that to the power n, divided by, because we're multiplying, divided by root 1 plus x squared under square root. And that will be our final answer for this question. So that is it for today. I hope you've learned some things. Practice. So with practice, you will learn more things. But yeah, that'll be it for today. And I hope you learned something and that you're going to practice these questions. Try practicing these questions without seeing them. Try understanding them fully and then practice them without actually seeing them. That way you're going to get the gist of things, you're going to understand your rules, and you must know your rules by heart as well, so that you're able to apply them. And then after that, everything else will just come to you easily. And then you must also, practice other different questions. So yeah, that will be it for today. Thank you.